Let us practice problems associated with bomb calorimetry by considering the following situation. A nutrient is burned in a calorimeter and the temperature rose by 3.22 degrees Celsius. When a current of 1.34 amperes from a 10-volt source flowed through a heater in the same calorimeter for 460 seconds, the temperature rose by 4.17 degrees Celsius. The calorimeter contains 100.5 grams of water liquid. What is the heat capacity of the calorimeter, excluding water? What is the energy released by the combustion of the nutrient? There are two parts to this problem. The first sentence in the text of the problem describes the actual adiabatic bomb calorimetry experiment. The second sentence actually describes the calorimeter calibration to determine the quantity Ccal, the heat capacity of the empty calorimeter, or the calorimeter without the water. In all cases, the calorimeter contains a well-defined amount of liquid water, 100.5 grams. We remember that we need the quantity Ccal if we want to relate the temperature rise during the experiments to the heat of the reaction. In the first step of this problem, we express Q heater as the product of I times V times T. Each quantity is written in SI units, so we get Q heater equal to 1.34 amperes times 10 volts times 460 seconds, which yields 6,164 joules. We equate this quantity to the sum of the heat capacity of water and the heat capacity of the empty calorimeter times delta T, and get Ccal equals I times V times T divided by delta T minus the mass of water times the specific heat capacity of water equals 6,164 joules divided by 4.17 degrees Celsius minus 100.5 grams times 4.184 joules per gram per Kelvin equals 1057.69 joules per Kelvin. Now we know the heat capacity of the empty calorimeter, so we can use that information to find Q reaction. We write Q reaction plus Q empty calorimeter plus Q water equals 0, since we have an adiabatic process. We substitute Q empty calorimeter by Ccal times delta T and Q water by mass of water times the specific heat capacity of water times delta T. Delta T is equal to 3.22 degrees Celsius for the combustion of the nutrient. The mass of water is still 100.5 grams and the specific heat capacity of water is 4.184 joules per degree Celsius per gram. This leads to Q reaction equals minus 4,759.73 joules. The final result must be expressed with the three significant figures, so we get Q reactions equals minus 4,760 joules.